Hello again in this awesome tutorial. We stopping here. Okay? In the last tutorial, we discussing about this curve. So here we need to discover the relationship between the year sold and the sales price. And to do this, we call this function of plot to see the sense of this curve. Okay? So if we look in here, the relationship which is between years all sold and the median house price, we see this curve how it is. So it's increasing this 2006 to 2007. And we look in here, this curve is rise again here. Maybe a cause of this recession we have. So we see here, this x-axis we have here sold and the median house price. So after we look in this curve, the price is increased by time. We have maybe some hypothesis can explain why. Okay, maybe personally my own hypothesis here is recession, cause of recession. So if we continue here, so here we compare the difference between all the years feature with sales price. So we need to see the difference between these years and the sales price. Well, for feature, the feature again, I use this loop. Okay. Well, if the feature is different for units sold, okay, if this feature is different for years of sold, okay, I need to make a copy of this data based on this condition we have. Well, we compare the difference between years variable and years the house was sold for. So for data feature equal to the data years of sold of data of feature. Okay, that's mean we making the difference here. The data feature equal to data of years sold. Okay, years of sold minus the data of this feature. Well, so here we scatter this point. Plt.scatter data feature dot data source of price. Okay, I need to make a scale between this data feature and data for sales price. X-axis is features, y-axis is fixed, it's constant, so sales price, and we apply by show function. See our figure. So if we look in here, we have the years of build. Compare the sales price. You see here, um, scatter of this point we have here. Okay. Um, okay. The relation is not really clear, but okay. So we can see that in the feature engineering and so on. Well, this is the relation we have between these years of build and the sales price. So that's what we're looking here. Well, mm, so for year add or remote add, so this is the relationship. So if we look into we have some difference here. Okay, uh, scatter or the points is concentrated here in this area. Okay, but here no. So especially in this part, right part here, we're looking, we have also some scale point. Well, the same things for a type one, the garage build. Maybe like first figure, that's mean the year of build, because that's can explain it. Just the same year of build of a house is the same year of building the garage. Okay. A numerical variable are useful for two type. Okay. Here in the science we know for numerical variables we have two types. First one is continue variable and second one is discrete variable. For discrete variable, just some count number. You can see 1, 2, 3, 4, 5. For continue, gonna be like a measurement, like a width of health, for example, weight of height. So we have some float numbers. For this reason, it's called continue because we have a comma in those numbers. operating these discrete features, okay, with this condition. Well, discrete feature is feature for feature in numerical feature. If the length of this dataset of feature is unique, I need to be not duplicated, and is less than 25. I will show you now why I do that in the feature engineering. Here I need to check both of conditions. This is the first one. The length of this dataset is not will be duplicated, and the second part here is not the year feature. Okay. Well, this is the number of these discrete variables we have. Discrete variables count is 70. Okay. This is the number, how much of number of continue we have, or how much of continue or discrete variable we have here in this data set. We have 70. Well, this is all the features respect the condition or the criteria I make before. Well, here this is the values we have inside of these features. So, well, for discrete variable, this is all the discrete variable we have. If you look in, we have just integer number without a float or without a comma. We have 16, 1, 70, 0, 2, 1, 3, 4. Okay, those numbers called discrete numbers. So here is that is exist in statistics. Okay? Categorical, continual, discrete variable. Okay. Uh, so let's find the relationship between them and sales price. That's mean discrete variable. So if we look in here for feature and discrete feature, I want just to loop in over this discrete feature I chose before. I'm making a copy for this dataset from this dataset. Also, I grouped by this feature. Also, I want the median of the sales price of the houses, and I will make it like a parse. Okay? If we look in this X label, it's a feature, the name of feature we are interested with. And for Y-label, it's a constant, it's a sales price. Well, I give a title for each one of them because here we are looking over all these discrete variables here. That means I put the name of each features concerned with. Well, I apply this show here to show you this variables we have here. So if we look in, we have this is class. I don't have any idea really about what is mean this feature, but it's okay, just for education purpose. Well, we have different variables here with different colors. Each value is represented by some color. Well, since we have blue one here with 20 values, we have orange one with 13, 14 with green one, red one here with 45, purple one and 50, okay, the gray one, okay, each color here is represented by number. That means here show for us how much of this subclasses is most or in is a frequent in the relationship with the sales price here. Okay, well, so the symptoms would happen with this overall qual. Okay, we have the blue one here is most frequent contribute in this sales price. So in if we look in this overall qual, if we check in the none or the unique values we have, so we gonna found this one here 10 is the most frequent in this sales price. Okay, well, if we look in so over count also is the same with the purple one here is the most frequent. Okay, we have some values here. So here from 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 values here, 9 different values. If we look in also for the log wall find is if okay dispute. Okay, we have different color here with different values. Okay, I don't know what's mean that. But if we go deeply in this analysis, we can understand. Okay. We'll also for this PSTM fallback, we have some values here. We have 0, 1, 2, 4. We have red one, green, orange, and blue one. The most frequent here is green one. Okay. Also, we can see this PSM hold for PSM hold half bat. Okay. Here for bat, here for half bat. So we have it's the same. We have three colors That means three values here contribute in this feature. If we look in this full path, we have five values. The most frequent one is read one. Also here for half, but we have the other one is not frequent. We have here the bedroom of average maybe. The number of bedroom here. Okay, finally I found someone understand it. The number of bedroom we have here in this data set. So if we look in, we have the most one here zero bedroom. I don't know why. Okay, we have zero bedroom and price. So as I told you before, if you look in, so the bedrooms here, we have zero bedroom, and we have gray here with eight. Okay, I don't know how that is contribute to this site or to making this surprise. Also, we have a kitchen here, a number maybe of kitchens. We have a house with zero kitchen. Okay, and we have most of houses it's with one feature. That means the number of kitchen duplicated or the number of houses with one kitchen is most frequent. Okay. Also for continue, we have total rams a bit great. I don't know. Uh, this abbreviation is considered like a Chinese language, like Mandarin Chinese language, really. But it's okay. We have so this variable or this feature is represented with these colors. Okay. The most frequent one here is blue one. It's other. So like other color. Okay. Well, if you're looking also for the fireplaces, we have the most frequent here is green and a red one. We have that means we have two and three. Okay. So if we continue, we have the garage of cars. That means how much of garage. Also, we have a second feature is clear. We have the garage of cars. If you're looking, we have three garage of cars. That means those houses will be expensive. Uh, if someone have this house with three gardens, means it's a fat cat. A rich man. Okay, if we continue in this process, also we have this NS Porsche. I don't know what's mean that, but as we see, we have different colors. The most frequent here is this one. We have 304 and 153, and also for this pole area, here we have this paper one. We have 35555, most frequent one here. And if we look into for musical valve, musical valve, I don't know what is mean that also. We have this different combination of colors with these values here in this axis, with this x-axis. So we have not sold, okay, not sold. Well, so we have all these variables so show for us how contribute against this sell price. Well, if we're looking for a continuous variable, I mean we have some values with a comma. Also, I store those variables here in this continue feature. For feature in feature numerical feature, if the feature not in discrete variable, that means I want those variables not in discrete feature plus the year of feature. Okay, I want this year. Well, so if we look in here, let's analyze the continuous value by creating the histogram of understanding distribution. Because here we have the continuous variables, and to understand or to visualize this kind of or this type of variables, we need to make it like a histogram because that give you the density and they give you the distribution of this feature how it is. Maybe you can give us how it is distribution normal or not normal or Gaussian or exponential logarithmic or whatever. That's depend also depend on domain knowledge also. Well, we have the feature in the continuous feature data is equal to data set copy. I creating a copy again from this data set we have. Data feature is the histogram. I will pins 25 pins for this histogram. Well, X label features count together the number of most frequent values here. So if we count the first one here, lot of frontage. So we have this distribution here, how it is. Okay. Most of data is frequent here. There's a lot of fringes here in this area between 20 and 80. Okay. So if you look in the median here, the most frequent values is here between in this interval of 50 and 100. So if we're looking again for the lot area, the area of the houses is between 0 to, I don't know, maybe it's 14,000 maybe. Yeah. Areas between 0 to 14,000. Okay. Almost of the area of these houses is concentrated, condensed here in this place or in this interval. Well, if we're looking for the other feature, it's mass parent area. I don't know what it means that. Okay, well, we are looking at data, which is maybe this is outliers. Okay, I don't know. Have the most frequent data is here in this histogram or in these pins of zero. Okay, this means it's coming in from zero to another some values here, 0 to 20, 0 to 50 maybe. Okay, well, if we still continue, we have SAT is one, so we have distribution how it is. Maybe logarithmic distribution maybe for this distribution is look like that. It's price. Okay. They have maybe then I will lift left squared squared as well. The center of data is here in this right side. Okay. We have ancient fins also. We have some few values here. Okay. Most frequent one is here in this zero between zero and some other values here. Well, if we still can hear BSMT and if also we have this distribution how it is, okay, logarithmic, not logarithmic, okay, well, this shape of data is price, okay, so we also for total BSM we have distribution how it is, like a curve here, maybe it's near, or these are distribution of normal or Gaussian distribution. Well, also for this STF, LFF, I don't know on this one is the F failure F. Okay, so this is distribution here. Also for the others one, so the live area how it is, garage area. That means the area of garage. The most frequent area of this garage is here between 2,000 and 8,000 or 60,000. That means most of area or most area of this garage is concentrated in this country. Well, if I still continue, this is all the distributions we have. Okay. If we go to this explore data analysis part 2, we need to make some transformation using this logarithmic transformation. Why? Because we have a huge number. So if we look in here, I will put you in this data at first. Okay. So if we look in here, we have, for example, the years of build, and we have five between 5 and 2003. Big number. Also for the price. Why we need to make this transformation? Because we have a lot of numbers. We have numbers, big numbers and small numbers. Cannot compare, for example, 0 and 2002 or 972 or 608 1 and 6, 1 or 0. If we make this comparison between 0 and 1 and 2 and 600, it's a big number. So for this reason, we need to make this transformation with logarithm transformation. Okay. Can make I need to see, we can make use of information we want. We need just justify why. Well, for feature in this continue feature, I am making this copy also. I need to verify this condition if zero in this feature. So if this zero in this data feature is unique, we pass. We cannot make any processing. Otherwise, we need to make that. So data feature equal to lp.log, log of all these features. That means we need to make all these features in inside of this or I need I need to include this function of log for any data we have here. For sales price also we need to increase to make it small numbers compared to other features. We need to scatter all these ones data feature data so after transformation. Topic label is clear when label title and show. Okay, when looking now go to this x-axis, we look in this range numbers we have between 3 and 5. And also for sales price. Maybe now is more clear. Okay. Here we have the data is more concentrated. Here is more rotation. Okay, maybe it's more clear compared to the first time. So the same thing for loan area and sales price. Most of data is concentrated between 8 and 9, and 10 also between 8 and 10. Okay, maybe it's more clear now. So for is one is the FCA and also for belief area and for sales price and the first price we give us the straight line because we have same variables. Okay. Well, to detect the outliers, we have a technique, the box plot. So provided by this application of Seaborn, with same syntax. Why I losing a lot of times this loop because we have a lot of features, 18 or 81 maybe. That's it. Very hard really to copy. But when we go in deeply, if we want to create in a professional notebook, we should do that. Each variable we need to make it separately from others and writing some observation about each feature. But here it's okay. For feature in the continue feature, data is copy okay from this dataset we have. For zero in the dataset feature is unique, we pass. Otherwise, we are making this information with no function. Well, this is what we found after this transformation using this log function. Okay. Uh, okay. Well, so with this box plot as we see, we have this as price. This is here out of this box plot is called outlier. That means it's some values is out of range of data, and that it's make our models very weak. Usually, we have some models that are very sensitive to outliers. Well, here the box plot gives us the ability to see the outliers here in the left, in the bottom, and in the above of the box. Especially here in the load area, as we see, we have much black dots here. That means we have much or huge number of outliers. Also, for these loss conditions, those same things happen. Well, we lead this transformation. If we go to other types, category variables, we see the discrete and continue. Now we go to the character variables. When in this kind of variables, well to select from dataset just category of features. So feature for feature in dataset.columns if data feature dot type is equal to 0 between or O between quotes. Here that means string. I want just string variable. So after I run this cell, I got this things here. I have a lot of category variables. Okay. And if we look at the five top reports, we see how just we have categorical as values for each feature for each variable we have here. So that's what we look at. See the difference between the numerical and the category variables. Okay, and of course we cannot give for our model those kind of values. We need to make it transformation before trying make any prediction. Because in machine learning, our model cannot understand uh, how those variables, those values work. Well, here we look in how much duplicates of data for each categorical. So for image none, for example, a number we have five. Okay, I look I writing and looking for each category feature. Prime feature is format function here. Calibrates here. A number of categories over categories for format feature or need of the feature in looking at what we have. For first one, we have his non and number of categories is five. For this second one is two, three, four, 25 for this neighborhood. Number of neighborhood per operation. Neighbor we have 25. That means we don't have the high density of people. So if we're looking for each variables, we have a number of duplicated or a number of unique values we have. So if we log in, if we go in, sorry, for this bar, okay, because we're using the bar to see watch or the count for counting the number of most frequent values. So we have the same syntax here, like basically. So for this one, for this one, we have five. We have C all. We have B. We have air arch. We have air L. Air N. Most frequent one has a large in this one feature. Same times we have for street. We have wave and GF. Wave is most frequent. Okay. Now we have also this wave one here. We go. We have load shape. We have air one, air two, air three, rig. Most frequent is air two. Maybe the label of the okay. Well, around the counter, so we have white, now, HL, pink. So if we look in this, so for the variables, particular variable, we're using the bar, just checking each values we have here. Okay. House style, all, must verify, external wall, condition, and so on. HTML variables of five values, must frequencies are branch, and so on. Well, that's all we have for now. Okay. For sales type also we have really column love, collie, called, con, CMD, con. So that's all for this session. So I hope that's clear for you. Well, this part is so this part of analysis for just for data analysis for this ADA, okay, bigger brackets. So I hope that's clear for you. I see you in next tutorial. Thank you and happy learning for you again.